Well, actually, yes, recent advancement in CCUS focus on making carbon recovery more practical through innovative materials and designing streamlined processes, which means that they are more efficient. So developments have been focusing in creating integrated CO2 capture and utilization system, which combines capture and conversion steps together. Well, typically these systems leverage what we call dual functional materials, DFM, for example, which can do both absorbing CO2 and catalyze its conversion to interesting fuels such as methane or methanol. These integrated approach simplify operations and potentially reduces energy consumption. And so it means that the cost of the production could be reduced, which makes CCU applications economically more viable. Also, as this point I explained, other trend is using materials to lower carbon footprint. For instance, construction materials derived from CO2, such as aggregates or CO2 cured concretes, as well as synthesized fuels. These products, they can enable captured CO2 to replace conventional materials and lowering overall emissions. As much as industries are looking forward to technology advancement, the challenges in CCUS remain particularly around energy-intensive nature of some processes, which makes them make them economically less viable and costly infrastructures when it comes to sequestration, for example. It is essential to address these challenges by improved regulatory framework, carbon accounting, especially around e-fuel, credits, taxing, and also promoting, most importantly, the access to affordable renewable energy for scaling CCUS technologies to its full potential. But when we talk about scalability, of course, we should be able to implement CCUS technologies for larger scales. That's evident. But there might be also a need for scaling down by developing modular systems, which enhance the feasibility. Actually, modular approach could make implementing CCU easier across industrial sectors where traditional huge carbon capture or even storage projects would be impractical or too costly for some sectors. So, for example, in larger scale CCU projects, the transport of CO2 is one of the big challenges. But when it is done in a place where it can be sequestrated or used locally, then it removes all that part. It is actually this approach is closer to the approach of Nippon Gases that we are looking at. Instead of doing huge projects, doing smaller, more realistic and feasible with our client. That doesn't mean that we don't get involved in big projects. For example, Nippon Gases supplied CO2 for the commissioning of CO2 storage site in Norway. But we believe large projects are impressive, but small is also nice, proves technologies more practically, and also clear the path for larger projects to be set more easily.